Okay, so let's take a look at some of these problems for the lesson 1-7, the three-dimensional figures. And we're going to start with this very first one where you determine whether the solid is a polyhedron. Then we need to identify the solid. If it is a polyhedron, let's name the bases, the faces, the edges, and the vertices. So yes, it is a polyhedron, and we're going to call it a prism, but more specifically, it's going to be a rectangular prism. So I'm just going to go ahead and write rectangular prism because that is our polyhedron. And now we're going to start looking at the bases. I'm going to start by highlighting this bottom rectangle down here. That's going to be our first base. Okay, and we're going to call that guy rectangle. Since it's a rectangular prism, we're going to call that one rectangle MNOP. Our second base is the one that's going to be parallel right above it. And I'm going to highlight that guy in as best as I can. And that one's going to be also a rectangle, but we're going to call that one RSTQ. So those are going to be our two bases for the rectangular prism. Now, moving on to the faces, there's a bunch more of those. We're going to go ahead and keep these two because our bases are also going to be faces for this prism. But the first one we're going to look at, the next face we're going to look at is the one up here in the front. It's also a rectangle. We're going to call that guy QTOP. Moving on, we're going to look at the one right behind it, highlight that guy, like so, and then we're going to name him STON. STON. Okay? Then, going to keep going around the back here, highlight this guy here. We're going to name him RSNM. RSNM. Then the last one we've got here, over to the front, we're going to call this one RQPM. So again, these two here, I'm going to highlight them. These two here are going to be our bases, but all of these, I'm just going to highlight half of these just so you can see all the ones in green are going to be faces for our rectangular prism. Now let's talk about the edges of our rectangular prism, and I'm just going to highlight a few. That one there, just a few more. And since these are line segments, we're going to name these guys as line segments. So we've got R, M, and then S, N, T, O, and Q, P. Okay, now we've got a few more edges to look at. Let's go with that guy. Just next group of four that we're going to look at, and let's name those S, T, N, O, R, Q, and M, P. Okay, now we've just got a few more. Okay, we're going to go to the back now, and the two up here in the front. It's going to be RS, M, N, Q, T, P, O. And those are going to be all of our edges for our rectangular prism. Lastly, we just have our vertices, and those are just the points on our rectangular prism. So I'm just going to write those out. R, S, T, Q, and M, N, O, P. Just 8 vertices for this rectangular prism. This next solid, because it has a curved surface, is not a polyhedron. It has 2 congruent circular bases, so it's a cylinder. So the only bases it has, again, are the 2 circles. So it's going to be circle K and circle L. It has no vertices, no faces, no edges, nothing like that. And all it has are the 2 bases, circle K and circle L. Now, this solid is formed by polygonal faces, so it is a polyhedron. The base is a triangle, and the 3 faces meet in a vertex, so it is a triangular pyramid. Again, it's got a triangular base, and the other faces meet up at the top at a vertex, so this guy is going to be a triangular pyramid. Okay, we're going to look at the base. We just said it's a triangle. There it is down here at the bottom. I'm going to go ahead and highlight this guy for you here. So our base is going to be triangle A, B, C. We've got the base out of the way, so let's talk about the faces. I'm going to go ahead and highlight the first one that we're going to look at, just to make it easier for you to see what it is that I'm talking about. That triangle is a face, and we're going to name that guy triangle A, D, C. Now, the next one, which is right next to it on the other side, on the right side here, we're going to highlight that guy in. And that one's going to be called triangle C, D, B. And the final face to this triangle is the one in the back on the other side that you really can't see. If you were looking at this, you know, if it was sitting on top of a table, you wouldn't be able to see through it. But it is on the other side. That triangle back there, and we're going to call that guy triangle A, D, that's a D, B. Okay, so again, the one I'm highlighting first is our base. These other 3 are going to be the faces along with our base. Remember, that base also counts as a face. Let's move on to the edges. I'm going to go ahead and highlight a few of them. Okay. There's 3 right there, those 3 edges. Again, they're line segments. Line segment DA, line segment DC, and DB. Those are 3 edges. We've got a few more that we're going to take a look at here. The ones down here at the bottom, basically the perimeter of our base, line segment C, B, B, A, and A, C. Those are the 6. Those are going to be the 6 edges of our triangular pyramid. Lastly, we're going to talk about the vertices. Now, if we're just talking about the vertices of the polyhedron, okay, that would just be all the points. So I'm just going to say A, B, C, and D. But remember, the vertex of this triangular pyramid is going to be this one here at the top. Just if I'm asking what the vertices of the polyhedron are, it would be these 4 here. But if I asked you what the vertex of the pyramid was, that would be this guy here. Now let's get into some math. Let's go ahead and work with some numbers here and find the surface area and the volume of this solid. This solid is actually a cylinder, so I'm going to go ahead and begin by writing the formula for the surface area of a cylinder, which we know is going to be, I'm going to use SA, surface area equals 2 pi r h plus 2 pi r squared. Okay, and we're going to plug in the numbers that we know. 2 pi, The radius, that's r, is going to be 6. And the height of this cylinder is going to be 18 plus 2 pi r, again, which is 6 squared. Now, in the next line, I'm going to go ahead and multiply all the numbers that I have here without the pi. So 2 times 6 times 18 is going to be 216 times pi, can't forget the pi, plus 6 squared is 36. 36 times 2 is going to be 72 pi. Now we add those two together. 216 pi plus 72 pi is going to be 288 pi. We multiply those, that's going to be approximately 904.78 feet squared. Okay, remember, it's an area. We've got to use feet squared. Now we're going to go ahead and find out what the volume is. Remember, volume of a cylinder is equal to pi r squared times h. We know what pi is, which is 6 squared times h, which is 18. 6 squared is going to be 36. 36 times 18 is going to be 648 pi. Can't forget our pi. And that's going to be approximately 2,035.75 feet cubed. Again, feet cubed. It's a volume. Surface area is feet squared. Volume is feet cubed. Those are going to be the two answers for the surface area and the volume of this cylinder. Let's keep it going here with this rectangular prism. We're going to find the surface area and the volume of this guy. Let's go ahead and start with the surface area. Write our formula. Surface area equals capital P, big P, little h, plus 2, big B. Okay? Our perimeter, we're going to use, I'm going to highlight here our base that we're going to use for this guy, just so you guys don't get confused. Okay, so our base, the perimeter, is going to be 5.2 plus another 5.2 on this side, plus 10 plus 10. Okay, those four are going to be 30.4. Our height of this prism is going to be 6. I'm going to put that for the height, plus 2 times the base, the area of the base, and that's going to be 5.2 times 10, which is going to be 52. Okay, now 30.4 times 6 is going to give me 182.4 plus 2 times 52, which is 104. If we add those two together, we're going to get exactly 286.4 centimeters squared. Just want to keep reiterating the fact that it's going to be centimeters squared. Okay, now let's move over here and find the volume. Use a different color here. The volume is going to be just the area of the base times the height. Okay, the area of the base we just found over here, that's going to be 52. Our height is going to be 6. Multiply those two numbers together, 312 centimeters cubed. Again, centimeters cubed. We don't want to forget that. It could be just because it's the volume. Okay, squared, it's going to be for this area, cubed for the volume. Alright, the last problem deals with Mr. Sato and his pool, but unfortunately we are not going to actually do this problem today or tomorrow or the week after. We'll probably get to this one a little bit later on this semester or later on this year, but it's not one that I want you to focus on today. Okay, if you tried it, I apologize. I'm sorry. Great job. We'll get to it later. The ones I want you to get a very good grasp of are the surface area and the volume of these two solids that we've just done. If you have, we are done with 1-7. We are done with chapter 1. I know it was a long one. There's a lot of vocabulary, and hopefully you will be studying soon for the chapter 1 test. Again, if you have any problems, any questions with these problems, please let me know.